All right, we're going to work on graphing logarithms. Now, to understand how to graph a logarithm, it really helps to remember how we graphed exponentials. Because remember, logarithms are the inverses of exponentials. It just undoes exponentiation. So let's think. So this is 3 to the x, okay? So we've got our exponential growth right here. We've got some ordered pairs right here. We've got this asymptote at y equals 0. So hopefully y'all are pretty familiar with how to graph exponential functions. Now, what we want to do is we want to reverse this. We want to switch all of our inputs and all of our outputs because that's what an inverse does. It switches x and y. So what I can do here is every single point on here, I can just go ahead and reverse. Some notable points here I want you to notice. Whenever you do log base 3 of 1, that's 0. 3 to the 0 power is 1. Oops. 3, 1, 9, 2. All right. So let's graph this real quick. So 1/9, -2. Sorry, this is 1/3. 1/3, -1, 1, 0, 3, 1, 9, 2. Now, if you're not sure, as we get smaller and smaller and smaller, it's going to take something even more negative as an exponent to get this really small fraction. So we wind up going this way. Another way of figuring out what your asymptote is we had an asymptote at y equals 0. Well, if you switch x and y equals 0 becomes x equals 0. So we get a vertical asymptote for my logarithmic graph. X equals 0. Okay. Another way that you can kind of think of how things are going to get graphed is remember that inverses get reflected over the line y equals x. So you can see this is a reflection of this. This is a reflection of this. So they match each other in a lot of ways. Another thing I want to point out is remember how on every exponential function that we did, every parent exponential function, I should say, we had this point 0, 1, because anything to the 0 power is 1. Well, if we reverse that, there's a point that we're going to have on every logarithmic parent function graph, which is 1, 0. Okay, so every logarithmic parent function graph that we have, we're going to have this point to start off with. So when we start moving left, right, up, down, that's going to be a great reference point to see where we are. All right? Now let's look at another logarithmic graph, but this time we're going to look at it as an inverse to exponential decay. So like 1/3 to the x. So we've got this decaying exponential that we're going to reverse. Okay, we're going to undo. We're going to do the inverse. So again, I can just take all of my x's and y's and swap them. So, 0, 1/3, 1, 1, 9, 2. Again, I want you to notice we have this 1, 0 point. Okay, every single parent function logarithm is going to have that. So let's graph these real quick. So we've got 9, -2. This is kind of working backwards from how we normally do it, but 3, -1, 1, 0, 1/3, 1, 1/9. Sorry, this is closer to here. 1/9, 2, and here we go. And we still have that asymptote at y equals 0. So when we swap that, sorry, it's supposed to be an asymptote. That's going to be at x equals 0 again. All right. So it looks a little bit different than this, but it's still mirroring over that line y equals x. If you can't see it, this part right here, if you reflect it, becomes this part right here. This part right here, if you reflect it, becomes this part right here. So they're still reflections of each other. All right. Another thing I want to point out, I mentioned this in another video. For both of these guys, for the exponential, the domain was all real numbers, and the range was only positive numbers. Okay, had to be greater than 0. Well, when we reverse this, when we do the inverse, when we do logarithms, we switch x and y, which means we switch domain and range. If you watched the other video, you saw that we could not put 0 into our function. 0 could not be an input to the logarithm function. And it couldn't be a negative either, because it only accepts positives. What can it spit out? Well, it can spit out anything. It can spit out positives, it can spit out negatives, okay, or 0. All right? Now, this is good for now, but we need to know how to move it up, down, left, right, all that stuff. So let's tackle that real fast. All right. So let's look at kind of 2 of our parent functions here. We had the one that was kind of the inverse of exponential growth, and we have the one that's the inverse of exponential decay. And we know both of them have the point 1, 0. So the question is, what happens if I go from, say, log of 1/3 x to log of 1/3 x plus 2? So what happens if I take my output and I increase it by 2? Output, that's y's, okay? So I'm going to take all my outputs, I'm going to increase them by 2. So now I'm going to be starting at 1, 2. I should probably use a different color. Excuse my smudges. And now everything has been moved up by 2. Now, you'll notice what hasn't changed is my asymptote. My asymptote is still x equals 0. Because if you take that line and you move it up, you still have the same line. Nothing's going to happen to that unless we move it left and right. Let's try another one. Let's do f of x equals log base. Sorry, I don't know why I was doing 1/3 there. That's 3. Log base 3 of x minus 2. So I'm subtracting my input by 2. Well, if I want to get the same outputs, if I want to have kind of the same shape here, I'm going to have to undo that. I'm going to have to increase all of my inputs by 2. That means moving 2 to the right. So instead of starting at 1, 0, I'm going to start at 3, 0. And still going to be increasing this way, but one slight difference. Where is my asymptote going to be? Remember, it was at x equals 0, but I moved everything over 2. So now my asymptote is going to be at x equals 2. It's shifted over 2, just like everything else did. So those are kind of the different ways that we can move this around. Let's take a look at a decay one real quick, just to make sure that we've got this solid. Sure, I'll use green. So graphed here is f of x equals log base 1/3 of x. Okay, so we're going to invert some exponential decay here. But let's take this guy. We'll do a couple things. Let's take this guy and do -3. Actually, we'll do +3 -4. All right. Cut off just a little bit. So let's think. So this is my point. How am I going to move this? Well, I'm going to move it down 4. And all my inputs are being increased by 3. So to undo that, I have to subtract 3. 1, 2, 3. So I'm going to be all the way over here. So my y got decreased by 4. My x got decreased by 3. Okay. What happened to my asymptote? Well, the up and down did not affect my asymptote because it was already a vertical line. But my asymptote moved 3 to the left. So this would be x equals -3. So it's going to go like that. All right. So that's how we graph logarithms. I could show you other stuff. I can make negative. Negative's going to reflect over the y-axis. But everything else is basically going to stay the same.